Welcome back. This is K. Priya of Web Semester, studying in Sri Venkateswara College of Engineering, Bangalore. And today my topic is about network application architectures. Now let us see the introduction of network application architectures. Network application architectures refer to the design and structure of software application that operate over computer networks. These architectures are crucial in determining how different components of an application interact with each other, how data is transmitted over the network, and how the overall system is organized. Several common network application architectures exist, each with its own characteristics and advantages. There are many types of network application architectures, and they are client-server architecture, peer-to-peer architecture, three-tier architecture, microservices architecture, service-oriented architecture, event-driven architecture, serverless architecture, and hybrid architecture. These are the types of network application architectures. Now let us discuss each one in detail. And now let us discuss about client-server architecture. Client-server architecture of a computer network in which many clients request and receive service from a centralized server. Client computers provide an interface to allow a computer user to request services of the server and to display the results the service return. The servers wait for requests to arrive from clients and then respond to them. Ideally, a server provides a standardized, transparent interface to clients so that the clients need not to be aware of the specifies of the system. Clients are often situated at workstations or on personal computers, while servers are located elsewhere on the network, usually on more powerful machines. This computing model is especially effective when clients and the server each have distinct tasks and they routinely perform. In hospital data processing, for example, a client computer can be running an application program for entering patient information, while the server computer is running on another program that manages the database in which the information is permanently stored. Peer-to-peer architecture. In a peer-to-peer architecture, each node can act both as a client and a server, meaning that it can request and provide resources to other nodes without the need for a central authority or coordinator. Examples of P2P applications include file sharing, video streaming, and online gaming. The main advantages of P2P include reducing the load and cost of servers, increasing the availability and reliability of resources, and enhancing the privacy and anonymity of nodes. However, P2P can also be difficult to manage and secure due to varying capabilities, configurations, and trust level among nodes. In addition, it is vulnerable to attacks and abuses such as malware, copyright infringement, and free riding. Moreover, its efficiency and can be inconsistent due to varying bandwidth, latency, and availability. Advantages of peer-to-peer architecture are centralized data management, scalability, easier maintenance, and updates. Three-tier architecture. Three-tier architecture is a well-established software application architecture that organizes applications into three logical and physical computing tiers. The presentation tier or user interface, the application tier where data is processed, and the data tier where the data associated with the application is stored and managed. The chief benefit of three-tier architecture is that because each tier runs on its own infrastructure, each tier can be developed simultaneously by a separate development team and can be updated or scaled as needed without impacting the other tiers. For decades, three-tier architecture was the prevailing architecture for client-server application. Today, most three-tier applications are targets for modernization using cloud-native technology such as containers, microservices, and for migration to the cloud. The main advantage of three-tier architecture is modularity, easier maintenance, and scalability. Microservices architecture. In software engineering, a microservice architecture is a variant of the service-oriented architecture structural style. It is an architectural pattern that arranges an application as a collection of loosely coupled, fine-grained services communicating through lightweight protocols. One of its goals is that teams can develop and deploy their services independently of others. This is achieved by the reduction of several dependencies in the code base, allowing developers to evolve their services with limited restrictions from users and for additional complexity to be hidden from users. As a consequence, organizations are able to develop software with fast growth and size, as well as use off the shelf services more easily. Communication requirements are reduced. These benefits come at a cost to maintaining the decoupling. Interfaces need to be designed carefully and treated as a public API. One technique that is used is having multiple interfaces on the same service or multiple versions of the same service so as to not disrupt existing users of the code. The advantages of microservices architecture is flexibility, scalability, independent deployment of services. Service-oriented architecture, that is known as SOA. Service-oriented architecture is a stage in the evolution of application development and integration. It defines a way to make software components reusable using the interfaces. Formally, SOA is an architecture approach in which applications make use of services available in the network. In this architecture, services are provided to form application to a network called over the internet. It uses common communication standards to speed up or streamline the service integration in applications. Each service with SOA is a complete business function in itself. The services are published in such a way that it makes it easy for developers to assemble their apps using through services. SOA allows user to combine a large number of facilities from existing services to form application. SOA-based computing packages functionalities into a set of interoperable services which can be integrated to different software systems belonging to separate business domain. The main advantages of SOA are reusability of services, interoperability, and flexibility. Event-driven architecture. Event-driven architecture is a style that organizes a system as a set of loosely coupled components that communicate and coordinate through events. Each component can act as an event producer and event consumer or both, depending on its role and functionality. Event producers generate and emit events to notify other components about something that happened or a change in the system. Event consumers subscribe to and process events that are of interest to them, either by reacting, transforming, or forwarding them. Event-driven architecture relies on an event bus or block that meditates the event flow between the components and ensure reliable delivery and routine. A good choice of architecture allows the solution to express harmony with the problem and the environment. Event-driven architecture enables us to solve problems in an environment of interconnected agents undergoing continuous change, and the challenges is to able to react to changes and derive maximum business value. The advantage of event-driven architectures: loose coupling, responsiveness to real-time events. Serverless architecture. Architecture is a way to build and run applications and services without having to manage infrastructure. Your applications still run on servers, but all the service management is done by AWS. You are no longer have to run provision, scale, and maintain servers to run your application databases and storage system. Why use of serviceless architecture? By using a serverless architecture, your developers can focus on their core product instead of worrying about managing and operating servers or runtimes, either in the cloud or on premises. This reduced overhead lets developers reclaim time and energy that can be spent on developing great products with scale that are reliable. Advantages of serverless architecture: cost efficiency, automatic scalability, and reduced operational overhead. Hybrid architectures, which are sequential combinations of the fundamental algorithms and are employed in various situations depending on the data type of the issue to be addressed, sometimes utilized since numerous application scenarios need diverse data kinds as inputs. In certain situations, an additional layer may be introduced to ensure that two distinct DL structures may coexist harmoniously. For example, with an AE or a GAN that can be used as a pre-training model and CAN that can be used as a feature extractor, or an RNN structure with various combinations of AE plus CNN. And whereas GAN plus CNN, etc., useful HODs can be obtained. The conclusion of today's topic is the choice of network application architectures depends on various factors such as the nature of application, scalability, requirements, development, team expertise, and specific use case consideration. Thank you for watching my video. If you like this video, please like, share, and subscribe to my channel. Thank you.